Hi, today we're going to learn how to process 2D RGB drone imagery on Drone2Map. We are going to be processing images that were collected with a Phantom 4 Pro version 2.0 quadcopter. We created our flight plan on Pix4D capture and captured a total of 174 images. Just a note on the formatting of those images, you need to make sure that they are saved as either a TIFF or a JPEG file or format before uploading to Drone2Map, and they need to include geolocation data, and that might be automatically added to your imagery, or you might get a separate CSV file that you need to upload to Drone2Map. We're also going to add ground control points to our data set. These aren't necessary, but it's good practice. We're going to add 5 of these. And again, you need to have your GCP data saved as either a text or a GCP file to upload them to Drone2Map. And then finally, we're going to process our data and generate 3 different data products. The first is going to be a 2D RGB orthomosaic, which is essentially a composite image of all 174 images that we collected together. This is done by generating type points, which is essentially just the software trying to find commonalities between all the images that were taken to create a composite image. We're also going to produce a digital surface model and digital terrain models. These are both types of digital elevation models. The only difference is that a digital surface model, which is this red line right here, is going to show us the elevation of all the features that the drone is surveying, whereas in a digital terrain model, which is this blue line, the drone is, or the software is going to ideally remove all the structures that are on top of the terrain to basically just give you the raw earth elevation. I have mixed feelings about how effective this processing or this output is on Drone2Map or any structure for motion software. So I would take these with a grain of salt, especially if you have very large buildings and structures. It's going to have a really hard time trying to generate those digital terrain models. So just keep that in mind. Okay, so now we're going to go through step by step. Okay, the first thing I do when I start a new project is I look at my images and I copy them into a new file. So I have all my images here, and what I'm looking for is I want to make sure that all my images were taken from my flight plan. So I want to make sure they weren't taken during takeoff and landing, basically. So all your images have to be saved as either a TIFF or a JPEG file, and they all have to be at the same height, depending on what kind of flight you're doing. But for this one, they all have to be at the same height. So I look at the first one usually, and then I just do a quick look all the way down to the bottom and they look okay. The other thing that I always check before I start is I want to make sure that I have my ground control points. If you're going to be using them, you need to have them saved beforehand, and you want them to be saved as either a CSV or a comma separated value file, or it has to be saved as a text file, okay? So now that we have all of our information ready, we can open up Drone2Map. And Drone2Map has a couple of options for their processing templates. The first one is a 2D rapid processing template. This will produce either orthomosaics or digital elevation models, but they're going to be a pretty low resolution. This is designed more for processing imagery in the field to make sure that everything is georeferenced correctly. We're going to be using the 2D full processing template today. We're going to be producing or generating an orthomosaic, as well as 2 different types of digital elevation models, a digital surface model and a digital terrain model. And then this template can also produce a multispectral orthomosaic, but in this case, we don't have a multispectral sensor, so we're just going to produce these 2. The last option that we have are 3D mapping outputs, and these are typically collected as oblique imagery, and this is used to generate these nice 3D models. But we're going to go ahead and open up our 2D full. We're going to do a test for our RGB 2D data. And then there's two ways that you can upload your images to Drone2Map. The first is you can do your images, and the way this would work is you have all your images and you can just click one and then do Control A. That'll click all of them, and then you just click OK. And you should see a nice green check mark on the left of all your images. The other option that you have for uploading imagery is the add folder, and this is pretty similar. You, instead of selecting individual images, you just add the entire folder. There's different reasons why you might want to do this. It's mainly just preference. Okay. And then again, you want to make sure that all your images have a checklist, a check on the left of them. And to be able to upload any imagery to Drone2Map, it needs to have lat, long, and altitude data associated to it, okay? So if your data doesn't automatically have GPS information, it will prompt you to then upload a file that has your GPS data saved to it. And I believe that has to be saved as a CSV file. When you first open up your project, you'll notice that you'll have your flight plan will be shown, as well as your individual images. You can actually click on these individual images to inspect them more closely. I always look at the first and my last image to make sure that the images were not taken during takeoff and landing. And then I always do just a quick look to make sure that everything looks correct, that they're all from the same flight, and everything looks good. So I'm going to X out of here. And then we're going to add ground control points to our project. There's a few different ways you can do this. We're going to add them from a CSV file in this case. If you want to learn how to download them from these 3 other methods, there are instructions in the Drone2Map help website. So to upload them, you're just going to find your CSV or your text file. Okay. And you need to know what the coordinate system your ground control point GPS points are in. So I know that they're in this ground control system, so I'm not worried about that. You can also upload control photos if that's something that's relevant to your research or to your work. And then you just have to upload your lat, long, and elevation data. You can also add accuracy information if you have it available to you. And then you want to select a label, or in this case, I have it as my GCP number, but this is really good for when you actually go in and mark your GCPs on your map, you'll know what the number it corresponds to. Okay, so it's going to upload our ground control point data, and it's going to display it as these X's right here. And so we're going to now mark them on our map. So you're going to click them and then click this button right here, which is the image link editor, and then it'll bring up this window right here, and then you'll see your ground control point numbers. And then what we're going to do is we're just going to go in and mark the center of our ground control points with a cross, and you're going to do it right in the middle. I try to zoom into more or less the same zoom level every time, so I try to go right at the size of the GCP, so it touches the size of the target when I zoom in. And you want to do this, usually the rule of thumb is between 3 and 8 times, and you want to have at least 3 ground control points. 5 is best as a minimum. And I would say whatever number you choose for adding to your ground control points, however many GCPs you choose to mark, I would add the same number to all of them. So I'm going to do 5, and I'm going to add 5 ground control points, these little X's 5 times, okay? So now we're going to go to our next one. And we're going to just do this for all of our ground control points. Okay, so I'm on my last ground control point. I've done a little bit of editing magic, so you wouldn't have to watch me mark these. And we are going to add 5 as we have for all of our other ground control points. And you'll notice that once you have at least 2, you'll get a green check mark next to your GCP right here. And you'll see I've added, it'll tell you how many links. So I have 5 links for all of them. Okay. And you just click OK. And you'll notice that when you place your GCPs, you want to be really mindful about how you do so. You don't want to put them right at the edge of your flight plan. And ideally, you want to have them kind of distributed somewhat randomly, but also evenly throughout your space, okay? So now you have your ground control point data. So now all that's left is you're going to go to options, and you're just going to review your processing parameters. So the first thing we look at is initial. And in the initial tab, we will always want to run an initial processing just for best practices. And then you can do a full or a rapid. A full is what we're going to do because we want the full resolution of our data. We want the highest quality. A rapid is what would be automatically selected if we click that 2D rapid processing template. Okay, so it's going to be low resolution, and that's not really what we're going for at this point. So we can also adjust how image pairs are made. I'm going to click the aerial grid or corridor because we did a flight plan, but you can do either a free flight or you can do some custom modifications if you have something that's going to make it hard for the matching image pairs to be generated automatically. So this is what we're going to generate today. So we're going to create an orthomosaic and we're going to generate it at the automatic one-time ground sampling distance. This means that your orthomosaic will have the same resolution as your raw imagery. You can upsample and increase the ground sampling distance if you want it to be a little bit of a lower resolution. So processing time might take a little bit less, or the file size might be a little bit smaller. And then also you can do user defined. So if you're trying to match your imagery to a different sensor or a different flight that was conducted at a different height, you can also change your ground sampling or your resolution that way. We're also going to generate a digital surface model, which is going to give us a representation of the terrain. And when we say surface, that's going to include everything, including our trees, our buildings, cars, everything. And then we're also going to generate a digital terrain model, which is going to display ideally just the terrain and essentially remove any trees, any cars, any other structures that are on that terrain, okay? So this is our parameters. So we're going to click OK, and then all you have to do is click Start, and you will see that your projects will be saved, and then you will see your initial processing start, and you'll be ready to go. Typically, this is going to take at least 20 minutes for any kind of project on Drone2Map. Drone imagery can be quite time intensive or processing intensive. So after your processing is done, you will see your orthomosaic potentially on your screen, as well as your other 2 processing outputs should be automatically loaded to your map. If they are not, you can access your products
Okay. You can access your products by going to the project file and then going to products, 2D, and then you'll see both your orthomosaic, which will be saved as a TIFF, as well as your digital elevation models, which will also be saved as TIFFs. And you'll have the full scale, and then you'll also have your tiles. Okay. So another thing that you really want to look at right when your project is generated is your report. So you can access your report by clicking this button right here, or you can also access where the project is saved. You want to be able to save your PDF file or share it with someone. That's how you get to it. And then there's your PDF file. So you go to report, and the first thing that you'll notice is that you have all your summary about your flight data up here. That does an initial quality check. So it found a good number of key points per image. It was able to calibrate all of my images. It has some issues with the relative difference between my initial and optimized internal camera parameters. This could be for a number of reasons, but we're not going to worry about them right now. Might be just because the drone wasn't calibrated properly or something. It found an acceptable number of median matches per image, and it was able to georeference. It had a root mean square error of 0.022, which caused it to have an advisory. These types of data are usually pretty hard to get nice or to get good results on because the drone does not like to stitch together images of aquatic systems because it's hard to find high points over water. Okay, there's not a lot of commonalities. So then we have some information about the tie points that are generated before our images, how much overlap you want this usually to be perfectly green in the middle. And you're going to notice there's not as, oh Lord, there's not as good of an overlap on the corners. And usually you don't want to make your flight plan too tight around your area of interest because the overlap in the corners is typically pretty poor. And if you do a pretty nice square flight, your overlaid edges are going to look a lot nicer than if you do an irregular shape for the most part. And then there's a lot of information about your report in here, and I'm not going to go through in detail, but there's a lot of information on the Drone2Map help website. So let's just look at our outputs really quickly. So here's our RGB orthomosaic. It's really nice. You can zoom in. You can see that our resolution is pretty darn good. And it's probably going to have some issues here in the water because things are moving around. So as you can see, the images aren't perfectly stitched together because these docks move around. But it's pretty good for how long it took to process and the fact that they are not stationary. You can also see your digital surface model. So this is showing us our elevation. I don't really like this color configuration. I think it's a little bit confusing. So I typically change it to a more gradual color scheme that makes more sense to my eyes. So something like this is fine. So essentially everything that's lighter is at a lower altitude and things that are at a higher altitude. And then you can do the same thing or a similar representation using a digital terrain model. These two are going to look really similar because this area didn't have a very large slope and it didn't really have a lot of trees or anything for the digital terrain model to remove. So those are our outputs. If you can do a couple of things at this point. You can export your data to GIS Pro if you want to do further analysis. You can also do some measurements if you like, which is pretty cool and useful. You can do area and volume measurements. You can also get image information. You just click on them. You can calculate vegetation indices. Most of these are designed for multispectral images. And then you can do elevation profiles as well as spectral profiles if you want to explore the spectral features of a specific area. And then you can also export rasters. So I hope you enjoyed this video. It's pretty straightforward. I will make another video on how to process multispectral imagery on Drone2Map, as well as how to process these types of imagery on Pix4D. So let me know in the comments below what kind of data you would like to see me process next, and y'all have a nice day.